Hello, we are back. I went and spent a bunch of money on books. Spent the rest of the weekend reading and coding and looking into the market. That's pretty much how I spend the weekends. Buying too many books, reading, and...
To details, I'm just pointing it out that sometimes the more complicated structures won't be enough and you'll need to use deep copy. But I'm leaving this up to you to look into if you ever find yourself in a situation where the copy is not enough.
What if I could build an app that works my way with Base 44? My work moves fast.
Okay, as usual, you know I'm not going to let you go just like that. Time to finish with a little practical exercise. This is to force you to really dig by yourself to trust on our as usual. Don't hesitate to go search the web for help. So the point of this exercise is basic first, for example, preparation. That you fit it into your with a loop again. You want to add a quantity key in each cryptocurrency dictionaries, and that quantity key should compute what is left of the amount of that cryptocurrency at the end of all those transactions. So indeed, those type of questions will ask you to use some if-else conditions, etc. Then, third question, now you need to add a key in each of the cryptocurrency dictionaries where you compute the P&L given a price of the currency today. And fourth question, you also add a key to those dictionaries where you store the result of the computation of the average purchase price for each of the cryptos. And we finish with a bonus question. This one is quite tricky. Here, for each crypto, we ask you to display the quantity purchased after the date of this one here. So that means you will need to do some tests, but also you will have to use the library for date. We will be looking into how to handle dates in a few chapters quite in depth. But here's a little introduction if you want to try to push yourself. They would be beneficial for you if you already tried to solve this question now. Anyway, as usual, you will find a link on our website to a suggestion of correction of this exercise. But again, the more you do by yourself, the better it is for you and your learning process. Also, don't write all that by yourself. Just come on the website and come and copy this transaction list. That's all for today, folks. You take care. Don't forget a little like and a subscription, and please share this course with anybody who might benefit from it. See you in the next chapter. Object-oriented programming is a fundamental concept in the world of algorithms. And you will quickly see that using such programming in Python will greatly simplify your work. This is primarily achieved through two essential concepts, functions and classes. And that's what we're going to cover in this chapter. For example, we'll use a function to compute compound interest, where we can easily tweak the parameters, while we'll be using a class to simulate a portfolio management, where multiple assets are being bought, sold, modified, etc. You'll see. If you want, there is a written version of this course available on our website. Links below. Now, let's get started. Alright, I've opened VS Code and we can create a new Jupyter notebook for this chapter. So, chapter 4, I, Y, and B. Great. And now what can we do? Well, let's create our first function. And this is done using the keyword def. So we start with writing def, which is short for definition. And then we write the name of that function, so compound interest. Parentheses. And then, as usual with a structure, we finish that first line with a column. Now if I press enter, I'll be in the function and VS Code has done the indentation for us automatically. And what should we do first? Well, let's just do a little print and say we'll print the word test. Great. Now if I run this, what do you think is going to come out? Well, let's discover it together.
If a cybersecurity or IT degree has been on your mind, check out UMGC. They're waiving their application fee through.
Oh, well, you see, nothing, absolutely nothing happened. And that's actually perfectly normal. Here, what we've done is that we've simply defined the function, but then we've never called it. And to call a function, you need simply to put its name below, so like that. So for example, if I run this now, what do we get? Well, we have the test, because we've called the function, and what does this function do? Well, this function prints test. That's all. So now we have this test printed because we've called it. And we could call it many times, no problem. So what's going to come out? Well, we'll have full test because we've called that function 4 times, and each time that function printed test. Great. Okay, you might be thinking at this point this function is a bit silly and doesn't have much use except maybe simplifying the code. That's true, but what becomes very interesting with functions is that you can give them parameters. So in the parenthesis, I have to write a name of a variable. So let me just say text. And now instead of printing test, I'm going to say print that variable text. So now, when I'm calling the function, I need to provide an argument to that parameter text, meaning in other words, give it a value. So let's say I want to print hello. So now, if I run that cell, we indeed have print hello. So really the cool thing here is that I can choose to give something different. I could say print world. And now if I run, well, I have hello printed, and then from this call, I have now world printed. I could have also put what parameter I'm giving a value to. So I could have written text equal and text equal here. Sometimes it makes things a bit more clearer to do that. So that would just give exactly the same thing. Okay, cool. This was our initial example, but let me now paste a function that does the proper computation of the compound interest. And you can see that this function has now 3 parameters. So the first one, what I call principal, is the initial amount of the investment. The compound, that's what world. And now if I run, well, I have hello printed, and then from this call, I have now world. I could have also put what parameter I'm giving a value to. So I could have written text equal and text equal here. Sometimes it makes things a bit more clearer to do that. So that would just give exactly the same thing. Okay, cool. This was our initial example, but let me now paste a function that does the proper computation of the compound interest. And you can see that this function has now 3 parameters. So the first one, what I call principal, is the initial amount of the investment. The rate then is the interest rate of that investment, while time here is the number of periods over which you want to do the computation. So if we computed something over 5 years, for example, we would put time equal to 5. Then first line, quite naturally, is the mathematical computation of the amount earned given that interest and those amount of periods. So here we apply the formula directly. So amount is equal to the initial amount, so the principal, times 1 plus the interest rate. But then don't forget that the 1 plus the interest rate needs to be taken to the power of the number of periods, so time. Remember that star in Python means to the power of. Okay, second line, what I'm now interested in actually for this computation is to know the amount of interest that we earn. So not the full amount that we'll get at the end of the investment, but simply the interest that we earn. So that's why we say interest is equal to amount minus the principal. Okay, great. Now last line. You discover for the first time this command called return. And that's really important for function. So you see this function doesn't print anything. It does a computation, and what we want that function to do is to return the result of that computation. So this is why we use this return command here. So we say return what? Well, return what is going to be computed in interest. So this also means that now if I'm using that function, I can do that. I can say A is equal to that function, and here what we will say, well, let's say that we'll start with an initial investment of 1,000 whatever US dollars if you want, Then the interest rate, well, let's say we'll go for a 5%. So I write 0.05. And then let's do the computation for 10 years. Okay, so if I run this, well, we don't see anything happening. We didn't do any prints, but it worked. The function compound interest did the computation of the interest with those values for our parameters. But it simply stored them in this A variable. So if we want to know what is A, what is the value of these interests, well, we have to do print A, very easy. Okay, great, let me run it, and we can see that this all amounts to an interest of almost 630. And again,
I did not get the same thing. 1,000, 0.0510. I don't see what would be different. Compound underscore interest 95. There we go.
no, I didn't do that, but if you feel that this makes more sense to you, you could totally...
That's crazy how one
yeah, so you
piece like that, you gotta be very careful.
You have to do it for all the
That's what I don't understand how these quants, like you really gotta test these algorithms. There's gotta be a way or a place to test all these, because you can really type something in and screw it up. It's kind of terrifying.
So here we'll have to put rate is equal to, and then finally here we have to put time is equal to. Great, so if I run it, we'll get the exact same result. Now from here we can start making things a bit more involved. Let me paste this little piece of code where I reuse the function, as you can see here. I store the result in.
Alright, what did he just do?
Now from here, rate is equal to, and then finally here, we have to put time is equal to. Great, so if I run it, we'll get the exact same result. Now from here, we can start making things a bit more involved. Let me paste this little piece of code where I reuse the function, as you can see here. I store the result in this interest variable, and then I print it nicely within a sentence. So a few things that happen here. First of all, you can see that when I call the function, I don't put the values of the parameters directly. I actually define some variables before with the values that I'm interested in, and I then plug in here the name of the variables. This makes it quite handy because now I can just come here and change things, and it's quite obvious, etc. I don't have to come and fiddle in the function. The other thing that you see is that the print here has something new that I haven't introduced yet in this course. You can see here this F. This is what we call basically the F-string notation. This is really handy because you see that in the middle of my string, I just came here and put a variable. And also some functions. You can put some functions and therefore it will return the value here inside, and then it will be printed. In other words, this prevents you from doing what we've seen before, where, for example, you would have to close your comma and put a plus to put your variable, then put another plus, open again the comma, etc. So it does shorten things and also helps make things clearer. Good. The other thing new that you see here is a function that we've never seen before. It's the function called round. So basically, the computation of interest will have a certain number of digits after the decimal point. Well, with this round function, I'm simply asking it to round up to 2 digits after the decimal. So let's print the result of this, and you can see that we get 216.65 euros. Here I said euros. Let me just change here now. You'll see that if I put a 3, indeed we get that we have 3 digits after the decimal point. Great. What could be interesting now is to bring in a little loop and use some lists. So we use these concepts that we've just seen recently in the previous chapters. And what we could do is, like, let's say I'm going to create a list. That's going to be a list with several years if you want. So I'll just put 10. Okay, let's do 10, 20, 30. Keep putting a space when I don't want to. Anyway, 5, 10, 20, 30. Round function and simply asking it to round up to 2 digits after the decimal. So let's print the result of this, and you can see that we get 216.65 euros. Yeah, I said euros. Let me just change here now. You'll see that if I put a 3, indeed we get that we have 3 digits after the decimal point. Great. What could be interesting now is to bring in a little loop and use some lists. So we use these concepts that we've just seen recently in the previous chapters. And what we could do is like, let's say I'm going to create a list. That's going to be a list with several years if you want. So I'll just put 10. Okay, let's do 10, 20, 30.
Control Alt 4.
Keep putting a space when I don't want to. Anyway, 5, 10, 20, 30 years, 40 years. And the point is,
Didn't do shit. It's not, it's Control Alt E, Control Alt E.
One thing I've noticed about football fans is they all talk like the players can actually hear them.
Welcome to PCR onto it. Step 2, 0, 8. A UK-based keyboard. The process is slightly different. Press and hold the alternate key and the control key simultaneously. Then press 4. Make sure you are using the numbers from the main keyboard, not the numeric keypad, as this method will not work with the numeric key.
Shit is not working.
How to type euro symbol on any keyboard in Windows 11, Windows 10 or any Windows operating system. First of all, just go to any software that you want to type euro symbol, just go to there, and on your keyboard, I just show, just hold Alt key, then just go to the num keypad, not this keypad, on num keyboard, just like 0, 1, 2, 8, okay? So I just go to my software, on my keyboard, I just hold Alt key, and just like 0, 1, 2, 8, and here is my euro symbol. Just type Alt key, just hold Alt key 0, 1, 2, 8, then release the Alt key, then our euro symbol is appear on just 8, and here is my euro symbol. Just type
to use this function and this little print to
Alright,
see
we're just gonna
how
put it down there for right
compound
now.
interest grows with the amount of years. So I've defined this list that I've called LI, whatever, short for list. So now we should do our for loop. So I will say for years, or let's say for Y, make it short, in what? In this list, LI, now a column, as usual. So this, we actually want to keep it in the loop. This has to be in the loop. And actually, I'm just going to take the years here, put it back in here, and say that years is going to be equal to what? Well, the thing that is scanning my loop, therefore a Y. So that's it. Okay, so let's run it and see what happens. Great. So we see after 5 years, that's what we had computed before. But now you see that after 10 years, almost $5,000, 20 years, 11, almost $12,000, 30 years, 22, 40 years, $40,000. And remember, this is only the interest, not including the principal. So, in other words, you really see with this example the power of compound interest. After 40 years, you earn
Alright,
almost...
something's not right. Something's still not right. LI 5, 10, 20, 30, 40, 5, 10, 20, 30, 40. It's working, it's just not showing up the same as this one. There we go. But then the numbers are still different. 10,000. You put a 4% interest rate. Okay. Yeah, there we go. Haha.
It's 4 times your principal amount in interest solely. Anyway, this was but one example, but you see that thanks to this example, we did a already quite intricate code. We have defined a function that does a computation for us. This function takes some physical parameters, physical between quotation marks, some real life tangible parameters. In the context of finance, we're talking initial investment, interest rate, time, etc. Now, we want to see the evolution of the interest that we can earn depending on the amount of years we do this investment for. So we're calling this Python object caller list rect. And then we use a loop to scan through these elements, and each time we use our function and we print the results. So I know I went a bit fast in doing this example. I kind of did that on purpose to stimulate you, but please do take time to understand it at your own rhythm. It'd be really beneficial if you get comfortable with what happens here. Now what I would like to show you is that you can give some default values to the parameters of your function. So let me put back this example and put it back the way we had done it first. So like this, and like this. Okay, and so to do this, what we're going to do is simply to put time equal to 5. So this means if you don't give time when you call the function, and actually we were going to simply remove the years here, well, the time used in the function is going to be the default value, which you have made it equal to 5. So let's see, if I run this code, what do we get? We get the compound interest after 40 years is 2,200 euros. And you can see that this corresponds to indeed 5 years. Also, I did that on purpose, but there is a mistake because we have 40 years here, but the default value should be 5. Now what is happening is that now that we gave the default value, we're no longer putting years here. So it is printing the value of years that was declared last. And you can see that we've actually defined it here in the loop. The last number of the loop was 40. So years at the end of this cell, once the cell was run, years is equal to 40. So really, this doesn't make any sense. What you should put now is simply remove it, and this as well. So, yeah, the compound interest is 2,000, and we know that it is for a default value of 5 years. But that doesn't mean now that you've given a default value that you can't give one. Of course, you can. We could put 10 years here if we wanted to, and now we'll get, indeed, the result that we had for 10 years. This is just a way of making your functions more versatile, where in certain uses you might want to give a parameter and not bother with that, and sometimes you will want to give it, so you can do this assigning this default value. And by the way, note that we could have done the way we did it before and add time equals 10. This would give the same value. But be careful, that doesn't mean we're now fixing check.
Alright, there we go. So, because this is still years.
Changing the default to 10. No. The default value is given when you're defining the function. Let me show you. If I now do this again and put it below, and now put it back to not giving the time, and therefore we'll call the default value, you will see that we get back to the result where we use 5 years. So keep that in mind. So now that we've introduced this notation as a means to give a default value to a parameter, I need to talk about some technicalities with the parameters a bit more. So this, in the Python jargon, a parameter defined with an equal like this, and the name is called a keyword parameter. while these ones here that don't have an equal are called positional parameters. And there's a good reason for that. That is because here the order in which you will give the value of these parameters is very important. So let me give you an example. And there's a good one with an equal like this, and the name is called a keyword parameter. While these ones here that don't have an equal are called positional parameters. And there's a good reason for that. That is because here the order in which you will give the value of these parameters is very important. So let me give you an example. So we'll go back to this, and actually we'll remove that, and then we'll say here, I'm going to say that my principal investment is, okay, we'll forget that, we'll just go very basic, so 10,000 here, and then I'll put a rate of 0.5. So this is going to give us whatever we've computed. We were going for 0.4, so let me show you. Okay, great, that's equal to that we had here. Very good. But now let's say we made a mistake and we forgot that the order was like that. Then if we do that, then the result that we're going to get is going to be completely different, because Python has no info about the fact that this in our head is actually the rate, while this is the principal. So Python is just applying the rules for positional argument, meaning first value that comes in goes into here, therefore it's used here and here in the computation, while the second parameter is put into here and therefore used in here in the computation. But now, with keyword argument, because you define them with a name, Python has the understanding of where it should be used, so their order doesn't matter anymore. Let me give you an example, and let's say we are turning this into a keyword argument and saying that the default value is 0.4. So now, I can totally do time is equal to 10 years, and rate is equal to 0.02. And this, as you will see, will run and will be, maybe I should put a principle that makes sense. Okay, and if I run it now, you see that we get the good answer. Because now Python here, knowing that these were defined with a name and an equal, it knows that, second argument, what is that? Oh, it's time. Oh, so it refers to time here and refers to time in my function, and the same for array. Last thing about all of this, you always have to define positional arguments first, and then the keywords argument. In other words, if you did this, and just put it like that at the beginning, Python is going to complain. And you can already see that VS Code was complaining, because you see you get an error, non-default argument follows default argument. So this is really up to you what you want to define as a keyword, what is as a positional. Again, this will depend on your problem. But what's important, the rule is that you always put the positional arguments first, and then the keyword arguments. And you can remember, positional means where the order is important. Okay, so we have seen the use of a function and some technical aspects with them, etc. But you might be wondering now, what is actually the purpose of a function? Because we could have just used this everywhere and never defined the function. Well, you must understand that in general you create a function because what the function does is something that you use several times in your code. So you don't want to have to write this thing again and again throughout your code. So here the illustration would be, well, simply later on you imagine in your code you have more computation of the compound interest, so you can simply call it now and just put, okay, we'll just leave those values like this, and you print it now, and you don't have to worry about how to compute the compound interest. You've done it once, it's done here, your code knows how it is done, and that's it. So you can compute it, use it as many times as you want. You know, you can carry on, I don't know, we do 0.5 here, and then we use it a second time here, and we put a 10, etc. Obviously, this is an example, it's a bit stupid, but think in terms of general code that now having defined a function really simplifies, because the computation that it does is coded once and for all in a corner of your code, and then you can reuse it as many times as you want. That's really the spirit.
Alright guys, I know this might seem...
Actually, you know what's funny about this? Let me see, I think the Brian Cox, I think I watched an interview with him. Never mind. Yeah, because I have a fascination in these black holes. Something about it. Earlier last year, actually around this time last year, I was sitting there thinking about Einstein's relativity equation and just a few other things related to this. And it hit me that black hole math and science is actually really important, because if there are such things, it could, and I guess that's why it's studied so extensively, but it could get us to a better understanding of our universe and how space and time align and make it happen. Wasn't a completed thought, but something about it rang that it actually is more important than people actually acknowledge. Yeah, so both of these gentlemen work at the University of Manchester. Hopefully this will be a good, I don't know about introduction, but a good primer on black holes. And I'll be able to do some of my own research into it and see if there's any takeaways. Black hole science. That with quantum physics and some mathematics. We're really trying to crack codes here and get to some universal understandings. It really plays into the simulation theory. We got this book on science, just a little history of science. Read up about it and on it and just try to see the different pieces of it. Yeah, the Newtonian revolution. Yeah, so we'll get into this. For a little primer, I've already made money a few times over. Lost it all. Made it back. Lost it again. Made it back. So it's not entirely a motivating factor. Clearly there's some importance just to be able to sustain and buy different things and be able to research without necessarily having to worry. But I don't. It's not really ever the main motivator. It really just becomes means to another end to be able to research and study and look into different ideas and research, really. But for you shallow people out there, it is cool to flex a bunch of money, I guess. But you gotta understand, all that is human created. And if you start getting too wrapped up in human creations, it becomes very easy to lose yourself. It's much more fun to be able to research and explore and create. Which again, money's a cool creation, I mean the idea of it. But the way humans value it, like it becomes everything, it's just not entirely true, because you can create something that then everybody wants to give you money for, and it's just as neat. So you said you're going? And I've read all the books, well, not all of them clearly, but I've read a bunch of the books on the Federal Reserve and money and Jekyll Island and economics. So there's also some hacking books that we're going to get into. We'll start seeing how these hackers make it happen. Yeah. Start to test out how we can break into different systems and test various systems, and then maybe we can offer cybersecurity to some people, I guess would be the goal. It's like if we know how they hack and how to combat them from hacking, then we'll go out and create a little company that offers safeguarding and protection. This is one way to make money off of it. Again, if you want to make money a bunch of ways. I mean, you're seeing these people who are hacking Bitcoin wallets. Yeah, again, pretty much we're going to be busy all year, all next year. The year after that, we pretty much are always busy. Oh, and I've also made money a few different ways. I used to sell real estate, really we buy it and then sell it. Made money in the markets, made money moving. Made money just working a traditional job. Well, pretty much have done a few things, I guess.
Functions are indeed a vast topic, but don't stress. With practice, creating and using functions will become second nature. And now, let's jump into the second big topic of this video, classes. So to define a class in Python, we use the word class. So just like we use the word def to define a function, for classes, it is the word class. So let's define a class called bank account. And you can note here that I am using a Pepe convention where for a class, we generally define its name in the following way. You start a word with a capital letter, and if your name contains several words, this time as compared to functions, we don't separate each word with an underscore. We simply put them together, but any new word will start with a capital letter. Okay, at the end of this name of the class, we don't put any parentheses, we simply put a column, and then we can start defining the main components in that class. The first thing that needs to be defined in a class is its constructor. So this is a method. So a method, if you want, is a function that exists within a class. That is why I'm starting the definition of the method with this def here. And so the constructor is always named with underscore underscore init underscore underscore. I put one too many, so 2 underscores. And then I'll put a parameter name that I call self. So this self here is very important because it represents an instance of the class. In other words, it is through this self that we will be able to access all the variables, attributes, and methods within that class. So this is a bit technical, but you'll get to understand that with some examples soon. So anyways, to finish the definition of this constructor, we finish the definition of a method as usual with a column. Just remember, a method, simply a function within that class, so same conventions. And let's say for this first example, in a constructor, I'm just going to say print. Okay, let's do initialization. There we go. Okay. So now let's use that class and create an instance with that class. So in other words, an instance is a representative of that class that will have all the properties that we've defined in here. So let's say account 1 is going to be equal to bank account, and here I have to put parentheses because I'm calling them. Note, however, that I don't need to fill in anything for the self. The self doesn't need to be given a argument. In other words, if this constructor was expecting a other parameter, so a for example, then here I would have to fill in a.
At Full Sail, our technology programs are designed with a different approach to learning. We let our students get hands-on and start.
But for this first example, we are not putting anything besides this self, so this account 1 equal bank account without anything in the parentheses is going to work. So let me simply run this, and you can see that we have indeed initialization that was printed. And note something important here, the fact that we've seen initialization printed here, what does it mean? Well, it means when you define an instance of that class by calling that class, then what happens is that automatically what is executed is what is in this init method. So that's why we call that a constructor, meaning as soon as you call the class, what is run is what is in here. Something I should also add on how to read this line is to say that account 1 is now defined to be an object of what type? Well, the type bank account. Now, let's add another method to this class. So I will call it, let's say, withdraw. So def withdraw, and again, because this is a method, we always have to start with the first parameter putting our self variable. So I'll finish also by putting one column, and let's say we just print withdraw for the moment. Okay, so if I actually run this cell, what is going to come out? Nothing changes. That's right, because we haven't called that method yet. If we want to call that method, we have to use the following syntax. So account 1 dot withdraw with a parenthesis, and we close it again because we don't call this self parameter. So if I run that cell, now we indeed see withdraw printed.
That did not work. Was that wrong? That did not work. Withdraw account 1 dot withdraw. Class bank account. Okay. It's really written the exact same. I don't understand. This one I don't understand. It's written the exact same. I don't think tabbing it over is going to do anything. What is going on? Why isn't this working? Account 1 dot withdraw.
Method yet. If we want to call that method, we have to use the following syntax. So account 1 dot withdraw with a parenthesis, and we close it again because we don't call this self parameter. So if I run that cell, now we indeed see withdraw printed. Note, however, that you've already seen this kind of thing where you have a
This is not working. Define withdrawal self. Can't be why. What the heck? Account. Oh, what the
point followed by method. Remember, for example, when we were doing some lists and we wanted to append a new string, so we had done something like this with our string in there. And so what actually happens here, so I think we did list 1 or whatever. Anyways, what actually happened here is that we had an instance of a class list. We were using the method that was defined within the list class, which is called append. So we're doing exactly the same, but this time we're defining the class ourselves. So yeah, for us, account 1 dot withdraw. So actually
bank account attribute error. Bank account object is no attribute withdraw. I thought that's why I was putting that dot there. It's really the same. I don't understand what would be typed different. What if, so if I'm basically saying if I take this out and then run it, see it still doesn't work. To keep going.
careful here. We are allowed to use account 1 dot withdraw because account 1 is an object of the type bank account, and in that bank account class we indeed have a method called withdraw. So say for example I removed it or simply.
So that's why he's saying that it works. What if we tab this? And just for initialization. Define initial.
Commented it. If I now run that cell, what happens? We get a attribute error saying bank account object has no attribute withdraw. Indeed, we had commented it. And also, now you should...
That's what I'm getting.
Called withdraw, because account 1 is an object of the type bank account, and in that bank account class, we indeed have a method.
Oh, that's why. Because it's not in the class, I see. Alright, this is gonna work now. Haha!
Called withdraw. So say for
It was outside of it, that's why. We got it. Look at that. I'm sitting there looking and... So, sometimes there's two things going on. It's either how it's typed or then how it's formatted. Typed and formatted.
removed it or simply commented it. If I now run that cell, what happens? We get a attribute error saying
We're almost halfway through this course too. This is the 5th video out of 11. The only thing is there's a few hour ones, so I have to go through those. What time is it? 8, 9, 10, 11. Be done this around like 1 a.m. I'll probably take a break here in a little bit, finish this all-in podcast, read a little bit, and then work on this throughout the night. Because then once I finish this is giving me a good understanding of Jupyter Notebooks and just VS Code and Python. Then we're going to go into more building the actual algorithms that will trade. Python, C++, and Java. See, that's why I want to get a book too on C++. I got this coding all-in-one that I think goes over C++, so I'll probably just read through that and then sharpen up where I'm feeling not as easy. Yeah, again, we're cooking up. It's a big cook-up. I'm gonna take a piss and we'll be back. How long have we been live? Maybe I'll cut it here. No, we didn't even make an hour yet. Yeah, we're gonna keep going.
For attribute withdrawal. Indeed, we had commented it. And also, now you should understand better what I said at the beginning with the representative, the instance being a representative. Because you see that now account 1 is a representative, if you want, of bank account, and it has all the properties that are contained in bank account. And for example, one of them was this def withdrawal, and that's why we were able to call it at this point here. Okay, moving on. Let's start adding some meaningful parameters to our class. So let's say we'll put a balance parameter in our constructor. And let's say that I want to print this balance. So I'll go balance here, and then when I'm calling the account 1 here and I'm defining it to be an instance of the class, I should give my balance at this point here. So note that the parameters of the constructor, you give them at the moment when you define the object representing that class. So the 10,000 is given at that point here. So okay, let me run this. And okay, you do see that we get our initialization followed by this 10,000 balance here. Great. Now let's say that we want to print the balance after calling the method withdraw. So at that point here. So let's do print balance. And let's run it. You actually see that the VS Code is complaining. But let me run it. You will see that we have a name error saying name balance is not defined in the function here. So you might think, well, that's weird because we've defined balance here and we filled it in at that point here, so why is it not recognizing balance? Well, from a logical point of view, balance, only the scope of balance, if you want, is existence of balance, is only within the function in it. So when we're calling withdraw, well, balance simply doesn't exist. And that's where this self parameter, a bit obscure parameter that we've been writing down so far, is so important. Because what we're going to do at this point here is we're going to do self.balance is equal to balance. So we're storing within the class itself a parameter called balance or self.balance that will take the value of balance that we define here. So now, if I run that, oh, again, the same error. That's normal. What we should put here now is the self.. And if we run that, now we do get the 10,000 printed.
Okay.
Great. Also, thanks to this little trick, we now are able to access the balance directly within the class. So if we did print account 1.balance, well, oh, I forgot a name, so dot balance. If I run the cell, then we indeed print our $10,000 balance. Nice. You should start to see that one of the benefits of using a class is to be able to make accessible variables and methods throughout the whole class using this self parameter. And we'll get to see that even more with the coming examples. But first, let's actually make this bank account and the withdrawal a bit more meaningful. So first, let me basically say that we will do an initialization with, and I'll put the balance here so we can print it directly, and I'll put an F string here, and I'll simply remove that there. So if I just comment this and now run it.
On August 22nd, I told viewers that the road to artificial general intelligence was already bringing massive change to society.
We should have initialization over 10,000, and let's say we're dealing with USD. It might make more sense. Okay, so that's done. So I mentioned that we'll make our withdrawal a bit more meaningful. So let's actually implement that when we run the withdrawal method, we are indeed withdrawing an amount. So here I'm going to add a parameter to that method. So I will call it amount, and now I will do, okay, I will also add an F string so we keep track of things, withdraw of, and then I put amount here. And rather than printing the balance, here we should actually do the computation where we will say that self balance is equal to self-balance minus, well, the amount that we're withdrawing, so minus amount. So you see what's happening here is that I'm using this balance that we set when we define our bank account 1 at this point here. But then when I call the withdrawal, I can give an amount, and this will update this self-balance. So let's actually do that so you see what I'm talking about. Let's say that we're withdrawing $2,000. So let's run it, and what do we see? Well, indeed, when we initialize our bank account here, we set that our balance is of $10,000. Then when to that account 1 we call the method withdraw with an amount of $2,000, we are effectively doing a withdrawal of $2,000. And when we print our account balance after having done that withdrawal, we have indeed $8,000. So I think you see here what I was just mentioning before changing this example, where we have been using this sort of general variable that we've defined. So this is when you define something with self, by the way, is what you call an attribute.
This did not work at all. Okay. That didn't work at all.
Thus, I'm not
So printf initialization with balance USD self.balance. Alright, that pretty much got removed. Class bank account, so define initial self-balance, printf. That's why.
So I mentioned that before. But so this is now a general variable that exists throughout the class, and you can see that we can use a method to change the value of this attribute. So this is really one of the big advantages of classes. Now, another advantage of defining classes like this is that once you've defined the structure, these methods, you can use them several times. So basically, we could define another bank account, say we will call it account 2, say that this account has maybe $5,000, and our first withdrawal that we do is of $1,000. So here I should also change to account 2. You see, I can run it, and the same things apply directly. So you see, it's the same idea as with functions. You define the structure, the methods, what it does, once and for all at some point in your code, and then you can use it as many times as you want. I've now pasted here an example a bit more involved of the bank account class. So you see it has 3 methods besides its constructor. You can see that here in the constructor, I'm also defining a default value for the balance, exactly like we did when we were doing it for functions. So basically, if I call the account like this, if I call bank account like this without putting any number here, then the balance will be automatically set to 0. So then the first method is the deposit method, and you can see that what this deposit method does quite naturally is that it adds the amount that you would feed to that method to our balance, and it also gives a nice little print of what's going on. In the same way, we have the withdraw method, a bit like what we did before, but be careful here, we added a nice little feature where there is a test, and basically if we try to withdraw an amount that's larger than the balance that we have on our account, then the withdrawal will not happen, but we will get a little print saying that we have an insufficient balance. And, well, if this is not the case, we do the withdrawal exactly like we did in the previous example, with also a nice little print to show what's going on. And finally, we have a display balance method, simply to display nicely the balance that we have in an account at any time we want. Okay, so time to play with this a bit. And let me copy this beginning of this example here, and we'll create a new one here, like this. I mustn't forget to run this cell to compile it, and now we can start with our example. So, okay, we're starting with a bank account with a balance of $10,000. So let's say first that maybe we got our salary, and
Finish this and then we'll be back later. Let's see.